So this is two trains run on parallel tracks. The first train leaves the city half an hour before the second train. The first train travels at 55 miles an hour. The second train travels at 65 miles an hour. How long does it take for the second train to pass the first train? So when will they be at the same point? All right. So these trains are leaving at the same time and they are ending at the same time. Train 1 and train 2, right? They're leaving at different times, but they're leaving at the same point in time. The point as far as distance goes, all right? So if this is train A and this is train B here, their distances should be the same, right? Their distances, because they leave at the same point and end at the same point, even though it's different times that they're traveling, okay? So we're going to set these two up. For the first train, rate times time equals distance, all right? Same for the second train. So we're going to fill in what we know. What is the rate of the first train? 55 miles an hour. All right. The first train leaves in half an hour before the second train. All right. Do we know how long the second train traveled? All right. So we know the second train travels that much time. All right. If it left a half an hour earlier, it will travel less time. Okay. If you leave earlier and you meet at the same point, you traveled less time. So the first train is traveling less time, t minus a half an hour. Right? T minus a half an hour. How fast did the second train travel? 65 miles an hour. 65 miles an hour. All right. Or sorry, this is plus. He travels more time. I said that backwards, by the way. All right. So if he left a half an hour before, I was thinking later, a half an hour before, he's traveling more time. The second one's traveling less. So you can either say the one that traveled more time is plus, the one that traveled less time is minus. Okay. One or the other. All right. So distance, what is distance going to equal? Distance is always rate times your time, right? Rate times your time. Same thing for the second guy, rate times your time. What do we know about these two distances? They are the same. In math, when they're the same, we put an equal sign. So we're going to say 55 t plus 1/2 equals 65 t. All right. So we're going to distribute here and we're going to solve. All right. Distribute 55t plus 55 over 2 equals 65t. All right. What do I do to solve this guy? I need to get what? My variables need to be on the same side of the equation, right? Same side of the equation. So if I subtract here, that will put 55 over 2 equals 10t, right? 10t. All right. How do I solve? Multiply both sides by what? Yeah, so divide by the fraction, which means we divide by 10. There's another way to do that. Multiply by what? Yeah, so I can multiply this by 1 over 10 since I have a fraction. All right, multiply by 1 over 10. All right, we get 55 over 20. I wouldn't leave that like that, would you? 55 over 20, that seems a weird way to write time. All right, so make this a mixed number. How many times does 20 go into 55? 2 times, with what left over? 15 out of 20. Now, you also don't leave time like this, okay? 15 out of 20. So this is the easiest way to do this. How many minutes are in an hour? 60. So I'm going to make this a denominator of 60. So I'm going to multiply this by 3, and I'm going to multiply this by 3. So I have 2, and then I have 45 out of 60, right? So this train here, T, is 2 hours and 45 minutes, right? 2 hours and 45 minutes. Does that make sense? And if you wanted to find this right here, it would be 2 hours and 15 minutes. 2 hours and 15 minutes. All right, 2 hours and 15 minutes. 3 hours, sorry. 3 hours and 15 minutes. No, whichever one it asks for. It's asking for the second train. Equations. So systems of equations we've been solving. You just took a quiz on it. We solved by graphing, by substitution, and by elimination. All right? Graphing, substitution, and elimination. All right? So we are going to now do application. So anytime you hear the word application in math, it means word problems. All right? So we're going to do 3 different types of word problems, and we're going to set up 2 different equations, and we're going to use one of these methods to solve. I will say for most of these, it's typically easiest to solve by elimination. For most of these word problems, graphing is not usually a good tool unless you're using a graphing utility. So unless you use like a graphing calculator or a graphing program on a calculator, because those are going to be more exact than what you could do if you just sketch a graph. So typically substitution and elimination, and very often elimination ends up being the easiest one. Let's look at the first example. Okay. A metal worker has some ingots of metal alloy that are 20% copper and others that are 60% copper. How many kilograms of each type of ingot should the metal worker combine to create 80 kilograms of a 52% copper alloy? All right. Lots of information here. Okay. The first type of metal alloy is 20% copper. The second type of metal alloy is 60% copper, all right? Those are our 2 variables because they want to know how much of each of those he has to use, all right? So you can use X and Y, you can use whatever you want, but you have to label it. So if I say X is going to equal my 20% copper and Y will equal my 60% copper, all right? My 60% copper, all right? He wants a total of how much? How many kilograms does he want if I add both of what I'm combining? 80. So that means for the first part of this, 80, right? 80 kilograms. Then my X plus my Y should equal 80, right? Makes sense? X plus Y should equal 80, all right? Specifically, he wants 52% of that, 52% copper, 52% copper. So I am going to now look at how to create my 52% copper. So I'm looking at the total mass, 80 grams, and then my total mass that's copper, all right? Total mass that's copper. So for my first one is how much copper? Well, my X is 20% copper. How do I write 20% as a decimal or a fraction? 0.2 as a decimal, as a fraction, 1/5, right? So 0.2, if you want to use decimals, X, plus how much is the copper of my Y? As a decimal would be 0.6 Y. And that total should be 52% of my total that I'm getting. What is the total that I'm going to have? 80, okay? So 20% of however much of the X I have and 60% of however much the Y I have should be 52% of the total that I'm going to have, which is going to be 80. All right. Does everybody see how I set up those 2? All right. Everybody see how I set up those 2. Now, in this case, it may be easier to use substitution because if I'm going to put those and try to add or whatever, then I'm going to have to multiply by a fraction or either get an all 2 whole numbers and do something else. So in this case, I'm probably going to use substitution. Definitely not going to use graphing here. Does anybody want to graph that right one? Like, no, we're not going to use graphing. That's not logical. So we're going to use substitution. And so for substitution, they substituted the X, got the X by itself for what they did. So let's just subtract our Y. So X equals 80 minus Y. All right, everybody see what I did? We're going to take that 80 minus Y and we are going to plug it in. And then we're going to solve. So we're going to say 0.2, and instead of X, we're going to say 80 minus Y plus 0.6 times Y equals 0.52 times 80. And we can actually go ahead and multiply that if we want. When you multiply this, remember you can just multiply your 2, just to remind you on decimals, right? 41, I started with 2 decimals, so 1, 2, 41.1. 41.6 would be my answer there. So 41.6 is what that's going to equal. All right. Now, how do I solve this? What do I do to solve? Distribute. I'm going to take my 0.2 and multiply, right? 0.2 times 80. All right. What's 2 times 80? 160. I have one decimal. So what's 0.2 times 80? 160 with one decimal would be 16. 16 minus 0.2y plus 0.6y equals 41.6, right? Combine my like terms. What are my like terms? The y's. I have a negative 0.2 and a positive 0.6. What do I have? 0.4. 16 plus 0.4y equals 41.6. What's my next step? Subtract my 16 from both sides, right? So I'm going to subtract 16, right? I get 0.4y equals 25.6. With subtraction, let's remind subtraction. Line up your decimals. 6 minus 0 is 6. Carry your 1. 11 minus 6 is 5. 3 minus 1 is 2. Pay attention when you do decimals. Line them up. So I have 0.4 y equals 25.6. My final step is to divide. Let's review dividing decimals. 25.6 divided by 0.4. What do? Move my decimal from the outside. If I move that one, I move this guy one. Decimal goes there, right? 4 into 25 goes how many times? 6 with 1 left over. 4 into 16, 4. So my y value here is 64 grams. 64 grams of which one? Which one's y? The 60%. 64 grams of the 60%. I need to do my x. X and y should equal 80. If x and y equal 80 and my y is 64, what is my x? 80 minus 64, right? So what is my x? Fast math here. 16 grams of 20%. That would be my answer. All right? So for this one, I have an x of 25% copper and a y of 50% copper, okay? So the x and y actually represent my total grams. So of those grams, 25% of those grams are copper. Of those grams, 50% of those grams are copper. So think about mixing metals, right? Mixing metals like an alloy. That's what we're doing. So my total grams, they're telling me, is going to be 40. So that means the total grams of the 25% and the total grams of the 50% are going to be 40. All right? And then specifically, they want that mixture to be 45% copper. So my next equation is going to be 0.25 times however many grams I have of that one, plus 0.5 of however many grams I have of this one, should equal 0.45 of my total grams there. Okay? So most of y'all had this set up correctly. All right? So now we're going to use substitution. We're going to subtract our y. X equals 40 minus y, or you could have subtracted your x. All right, if you subtracted your x, you're just going to solve for the other one first. All right, I'm going to take this and plug it in for my x. So I have 0.25x 40 minus y plus 0.5y equals, if you multiply this out, 0.45 times 40 is going to be 18. All right, if you multiply that out. Now, here's the deal. When I multiply this particular one, in my brain, I automatically converted this 0.25 to 1/4. Why would I do that? Because 1/4 times 40 is a really easy multiplication. It's just 10, right? Now, you can multiply by 0.25 and you'll just have to do your decimals. And it's still going to be 10. So here you get 0.25 times 40. We're going to get 10x here. I mean, not x. No x, sorry. My x should have been gone. I replaced it. So we're going to get 10 there minus 0.25y plus 0.5y equals 18. Again, you could do decimals or fractions, 1/4 and 1/2. The only problem I saw right here with a lot of you is this addition of your decimals, all right? So I have basically you're subtracting because you have a negative 0.25 and a positive 0.5. So I have 0.5 minus 0.25. You need to line up your decimals when you do this one, all right? Line up your decimals. So here I'm going to get 5, 2, I get a positive 0.25. All right, positive 0.25 when I add those two. So I get 10 plus 0.25 equals 18. I'm going to subtract 10. And I have 0.25y equals 8. Again, I would do a fraction here. You can do 8 divided by 0.25, all right? And you're going to have to move that over and divide by 25. 800 divided by 25, that's not a bad one. Or if you think of this as a fraction, that's 1/4 y equals 8. I multiply both sides by 4. That cancels here. 8 times 4 is 32. Y equals 32. So I know that I'm going to have 32 grams of my 50% copper. If they add up to 40, how many grams am I going to have left for my 25% copper? 8. So this is going to be 8 grams of 25% copper, and that would be my answer there. All right, when you hear the term break-even point in a business, what they mean is this is where you start making money, right? So before your break-even point, you are losing money. After your break-even point, you are earning money. At your break-even point, you're at 0, all right? So it means your expenses equal your income at your break-even point. And most businesses want to know this point. It's kind of important because they want to know when they can start making money, right? And so if they're selling items, they'll say we need to sell X number of items to break even, and any items we sell after that, it's profit, okay? So to compare your break-even point, you're going to compare your income to your expenses and where those equal. That's your break-even point. So when we set this one up, we're going to set up a problem for the money that accounts for all of our expenses, and then we're going to set one for the money that accounts for all of our income. All right? And so Y here is going to represent our money. So we're just going to represent the dollars for either our income or expenses. Y is going to represent money, okay? So the first thing they talk about is expenses. So we're going to look at expenses. Expenses are 90% per copy plus $600. What do we not know? We know $600, 90 cents per copy. What do we not know? How many copies? So how many copies is actually going to be our X here? So our X is going to be the number of copies. That's what we don't know. So now we're going to set up an equation for our expenses. Our expenses is going to be our dollars that we spend will equal 90 cents per copy. That's multiplication. 0.9 times X plus a flat amount of what? $600. That's my expenses. All right? That's my expenses. Let's look at income. Income. For this one, I make $1.50 per copy. That's my income. So my income equation, the money for my income will be 1.5 times the number of copies. Now this one is already set up with y is equal to something, all right? So when you have a variable equals something and the same variable equals something else, you have this on your quiz, you just need to set the two equations equal to each other, all right? And so that's what I'm going to do. I'm going to say, well, this equation, 0.9x plus 600, when it equals this equation, 1.5x, I'm at my break-even point. I'm at 0. My expenses equal my income, all right? This is an easy one to solve. How do I solve this? Over with subtraction, 0.9. Subtract 0.9. Again, watch lining up your decimals here. All right, line up those decimals. 15 minus 9 is what? 6, and I have that decimal there, so that's 0.6x, right? I'm going to solve by dividing by 0.6, all right? Now, again, when I divide by 0.6, and that's 600, right? 600. I didn't write my zeros in there when I pulled it down. When I divide with decimals, just move your decimal over. Whatever's on bottom, this is what would be on the outside. Move that over, move this over. So you have 6,000 divided by 6, which is easy, 1,000. What does that tell me? That tells me that at 1,000 copies, I will break even. And anything I do over 1,000 copies, I will make money. Anything less than 1,000 copies, I am in the red, right? I'm not making money. We have expenses. If I am writing an equation for my expenses, that is going to be 0.35 per copy, which I don't know how many copies yet, plus a total of 770 flat expenses. For income, I make 55 cents per copy. All right, so I'm going to set those equal to each other. I'm going to subtract my x's over. 770 equals 0.20x. If I divide, remember, I can just divide. I can make that 0.2. So divide by 0.2. Now, for this, if I just move one decimal place over, I have 7,700 divided by 2. All right, and that's where you're going to get your 3850. All right. So for this example, they're talking about an airplane. When you're in an airplane and you're flying against the wind, right? Against the wind, what's happening is that wind is pushing you this way while your plane is going this way. All right. And so you'll actually be fighting against each other. So what you have to do is you have to take your plane speed and you have to subtract what's happening with the wind. And that's your overall speed of how fast you're actually moving. Now on the opposite end, if you are going with the wind is pushing you, right? So you can actually take your speed and the speed of the wind and add them together because you're going to go that much faster with the wind. Think of it as like a boat with the current and against the current. If you've ever been in a boat, when you're going against the current, you are working this way and the current is working this way. You have to subtract the current from your speed of the boat because it's pushing against you. However, when you're going with the current is helping you move, all right? Has anybody been on a moving sidewalk in an airplane, on an airport, right? Yeah. You're walking at a speed and the moving sidewalk is walking. So you're going as fast as your speed and the moving sidewalk, right? If you were going the opposite direction, you would not be making as much progress. You'd have to subtract how fast it's going compared to how fast you're walking, okay? So that's what we're talking about when we start looking at these types of problems. You are actually going to be solving for the air speed and the wind speed, like the actual airplane, how fast it's going, and the wind, how fast the wind is moving. So let's look at this one together. Suppose you fly from Miami, Florida to San Francisco, California. It takes 6.5 hours to fly 2,600 miles against a headwind. The wind is moving up towards you, pushing against you. At the same time, your friend flies from San Francisco to Miami, same route. Her plane travels at the same average airspeed, but her flight only takes 5.2 hours. She is going with the wind, all right? It is not fighting against her. Find the average airspeed of the planes. Find the average airspeed of the wind, all right? So for this one, we are looking for the airplane speed and the wind speed. Wind, all right? So this is distance, rate, and time. Distance, rate, and time, okay? So for this one, my distance for both of these is 2,600. I have a rate and a time. So if I am going, if for the person that is going against the wind, all right, that is this first one. We know that by the term head. If it's at the head of the plane and pushing against it, it is against the wind. Tail is with the wind. Question. All right, so against the wind, we are going to take how fast the airplane is going, and we are going to subtract the wind speed because the wind is pushing against us. All right, subtract it. That is our rate. What is our time for the person that was going against the wind? So 6.5 times 6.5. That equals our distance. What was our distance here? 2,600. All right. That is against the wind, against the wind. All right. Let's look at the one going with the wind, with. For this one, we are going to add those. We're going to add those. That time looks like what? Yeah, 5.2. All right. And that also is 2,600. 2,600. All right. Now, here's a couple things I do here. When I'm doing something like this, I actually divide out that time first. All right. So for this one, I would actually divide by 6.5 first here. 6.5. And divide by 5.2. Divide by 5.2. All right. So for on the left-hand side, if I divide by 6.5, I just have A minus W. And on the bottom one, I have A plus W. All right. If I were to divide this, we're not going to go through dividing by decimals, you know that, but it's 500. So 500 here, 400 here. All right. So if I divide 2,600 by 6.5, I get 400. I divide 2,600 by 5.2, I get 500. For this one, I'm going to solve by addition. Always for these. I divide out that time first, and then I have a A plus W and an A minus W. It is set up perfectly for elimination, for addition here, okay? Because I already have a plus and minus my W, my wind. And so that's how I'm going to solve this one. I am going to add down. Add down. A plus A gives me 2A. My negative W and my positive W cancel, right? And then 400 plus 500 is 900. So how fast was the airplane going? 900 divided by 2. 450 miles per hour. Now, I actually have these two equations set up. 450 minus something equals 400. 450 plus something equals 500. How fast was the wind? If I go back to these, the airplane, 450 minus the wind is 400. How much was the wind? 50. So my airplane was going 450. My wind was 50 miles an hour.